So an iteration is the repetition of a mathematical or computational procedure, and it uses previous results to get to the next answer. So for example, this is a sequence of numbers, 10, 15, 20, 25, 30. Continues by going up by 5. Yep. Now we can write that as the next term is the previous term plus 5. Yeah? So 15 is 10 plus 5. 20 is 15 plus 5. 25 is 20 plus 5. Are we happy with that? So the next term is the previous term plus 5, and you have the starting term of 10. Now, the first iteration is, after the first iteration you get this value. That's actually term 2 in the sequence. So term 1, term 2, term 3, term 4. That's term 1, that's the value after the first iteration. So it's just language now. The value after the second iteration. Okay. And how would you put it in your calculator? You would do this. So what was the starting value? 10. So 10, press enter. Now if I press answer plus 5, it's going to take my previous result and add 5 every time.
Right, you recorded?
Yeah. Well, you can see it here, so...
Sorry, I didn't want to mess up your recording.
Yeah, that's okay. No worries. Alright. So, it's stored that rule now. Okay? So if I press it again, enter, I get 20. So it takes the previous answer and adds 5. It stores it as a recursive rule, and it will just keep going and adding 5 to the last result. Okay? So we're going to use this idea of iteration to solve for X intercepts using tangent lines. You all look so enthralled, so happy it's the end of term.
I believe you're actually teaching.
Yeah, I know.
Half the class isn't here.
That's why I'm doing the video. Ah, okay. Alright.
You going anywhere in Holland?
I'm going to Japan tomorrow.
Oh,
Yeah, I fly tomorrow, yeah.
For how long?
For like a week. To see. You're trying to, get me off on a tangent again. Right. So.
Your one was like really fast trying.
Yeah.
You going to skate?
No, it's awesome.
What's your plan?
Enough. I'll tell you later. Let's go through this. Right.
You got 12 minutes before your video.
Alright. Newton's method uses successive tangents, so one after the other, to find the X intercepts. So the process is, first you pick a point, right, to the right of your X intercept by making a guess. Find the equation of the tangent line at that point. Solve for the X intercept using y equals 0, and then use that X intercept to find the equation of the next tangent. So if I pick a point 6.01, what happens is that's 6.01, alright, and then I find the equation of the tangent at that point. Okay, this is the function y equals x squared minus 2. So I can find that xy point, can't I? Yes? So we have that point, and we can find the gradient of the function at that point. Do you agree? Using calculus? Yeah, I'll differentiate the function, and then I can get the gradient at that point by subbing in x is 6.01. Okay, so I have the gradient and a point. Can I find the equation of a line? Yeah. You have a gradient and a point, you can find the equation of the line. Now, how would you solve for the x-intercept for that tangent line? How would you solve for the x-intercept? If you find the equation of the line, make y equal 0. Yeah? So that's the idea. You find the x-intercept, and then you see, is it close to my x-intercept or not? It's closer, but not close enough. So we do it again from that point. Okay? We do it again, and it takes that xy point, find the derivative at that point, find the equation of the tangent line, find the x-intercept. Is that closer to my actual value? Yeah, a lot closer. Then we do it again. So just visually, can you see it's getting closer and closer to the x-intercept? Yep. And as it gets closer and closer, it approximates the 1.41, which we expect for, the square root of 2. Yep, that's the x-intercept. So we need to understand that process, but ultimately, for you guys, it's probably just knowing how to do it with your calculator. Okay, so I'll show you how to do it with your calculator, and then I'll show you why it works, and then I can tell you about Japan. Alright, so if I define my function to be x squared minus 2, right, then I can find the derivative of this. Yep, and I can define the derivative of this. So define the derivative to be, menu, calculus, derivative of f of x. Alright. Now this is just the process. This is how you put in your calculator. So what was my initial starting point, or my initial guess when I went through that example? It was x is 6, wasn't it? So 6 is my starting guess. I'm going to use that. Alright. So now I'm going to go answer minus f of answer divided by derivative of answer. Okay, then I get 3.166. Now that's stored as a rule now, because the calculator stores it as a rule. Press enter again, I get 1.89. Press enter again, I get 1.47. Press enter again, I get 1.41. Is it approaching the square root of 2? Yes. Okay, it gets closer and closer to the square root of 2. So that's how you do it with the calculator. Now, I'll just quickly show you why that works. So we get the idea that you take successive tangents and then you use the x-intercept point to make the next tangent, and you keep going till you find the best sort of approximation for the x-intercept. And the rule is given by the next x-intercept is the previous x-intercept minus the value of your function, so the y part divided by the derivative at that point of the previous x-intercept. And why does that work? It's derived from this formula, straight line formula. Yep. That's just a guess. Yeah, just pick a guess. So if the function looks funny, like we can't differentiate it normally, you might use an iterative process to find the x-intercept. And if you can graph it, because you know the rule, or your calculator spit out a certain rule for your function, then you can find x-intercepts by this iterative process. So we get the formula here from this. So you guys told me that to find x-intercepts to make y equals 0. Yeah? Okay. So do you guys agree that sorry for the guys watching at home, this one looks like this one? Is this a y value? F of a function, f of x, is that y? Yes. So this is y minus another y value. y1 minus y2, or y2 minus y1. Alright? This is the gradient at a point, which is m. Yep. Then you have the next x-coordinate minus the previous x-coordinate. So that's x2 minus x1. Alright? So we are trying to solve for x intercepts, and that's when y is 0. So if you sub y is 0 in there, and you rearrange that formula, you get back the one at the top there. X of the next term is x of the previous term minus that on that. So it's just a manipulation of your straight line formula using y equals 0. Okay? So in practice, you will just have to put into your CAS. And time in Melbourne's not 1:29 anymore. Lucky I didn't have anything else up there. No, I had some music going. The kids at Happy Homer Club were showing me. Happy Homer Club. What were they showing me? They were showing me this. Howl Wolf. You ready? Yeah, alright. Yeah. You're right. Face cam that?
Yeah, so you can see you rocking out to
Alright, alright. So again, we'll just show it visually, alright? So points on a curve, tangents, create your tangents, yeah? And the values get closer and closer to the x-intercept. Again, just to reiterate, all you guys are going to do is this. Type in your first guess, call it answer, and do answer minus f of answer divided by derivative of answer. Is that pretty easy? Okay.